Yeah, how many nights I've been in pain watching videos for how to take quizzes.
I started on my NHS application track, so no worries. Yeah.
Do you know Claire Frick? She's on her stand.
All right, guys, I guess we're not doing Minute of Silence today, so let's go ahead and get started here. So our plan for today is we're going to go over this handout you picked up, where I'm going to have you practice a few questions, see if you can fall into a common trap, and go over those questions. And then the bottom half of that is the question type we skipped on Monday. So I need to show you how to do that. And then once you know how to do those, you can do the one question that we skipped together on number 90, and you can do the one question that you skipped last time on 91, and then you have those finished up, and you can get all of that stuff turned into Google Classroom. So I don't have too much new to share with you today, but we do have our 3.1 quiz next class. So to prepare for that, I would make sure you feel comfortable with the notes. That was handout 89. Worksheet 1 and 2, that's 90 and 91, and then 92 that we're about to go over. So I'd say the quiz is probably most like 90 and 91 if you wanted to have an idea of what it may look like. That would be the closest to those. So this is a B week this week, so this is the last time I see y'all this week. So from now until next Monday, again, as always, there's a good chance you're not going to think about the quiz. So please set some sort of reminder so you don't feel caught off guard at least. Okay, so the top of this are the questions I'd like you to try real quick, just because they're ones that you should be able to do a pretty good job on, but there's one or two very common type of mistakes, and I want you to see if you fall into that before I just tell you what it is. So for these 8 questions without a calculator, tell me whether you think it's exponential growth, and you could just put EG is fine. Exponential decay, you could just say ED, or it could be neither if you think it's not exponential. So go ahead and look at those 8 and commit yourself to one of those 3 answers real quick. If you're not sure, just make your best guess, as if these type of questions will be on the quiz. So that's good for you to see if you make this mistake that I'm concerned about. Okay, does anybody need more time for those 8? then let's start off with the ones that would be neither. So an exponential function is where you have a variable in the exponent. So that was not true in question 8. The graph would grow pretty quickly, but it doesn't grow exponentially quickly. Also, number 5 doesn't have a variable in the exponent, so it's not a exponential function. But the other ones are either exponential growth or exponential decay. So an easy way to get most of this is it's going to grow if the base, which I'm going to call A, is between, exponential decay is going to be if the base is between 0 and 1. Negative just flips it over the x-axis, so that doesn't really change what type of growth it is. And then if it is bigger than 1, it's exponential decay. So in question 1, the base is between 0 and 1, so this one would be exponential decay. So on your notes last class, we graphed 1/2 to the x, and I talked about how 1/3 to the x, 1/5 to the x, and also 1/6 to the x basically look the same, all exponential decay. So here's where I get concerned. I think that a lot of people are going to call number 2 exponential decay, and this is why I had you try these before I talked about them, because the base is less than 1. The problem with this question is the exponent isn't x, it's negative x. So you have to do one step here for exponent rules before you can just apply this property. If you want to change this exponent of negative x to a positive x, the only way to do that is by doing the reciprocal of what it was being raised to. So 1/5 to the negative x is actually the same as 5 to the positive x. So this one is actually exponential growth. And if you're not taking into account that negative exponent, then you would miss that. Okay, number 3, positive x, base is bigger than 1, exponential growth. Down here on number 6, the base is 7. Multiplying it by 2 makes it grow bigger, but 7 to the x is going to grow exponentially. Number 7, same thing. The 1/3 is going to slow it down some, but 8 to the x is going to grow exponentially. And then you might be tempted to say this one's exponential growth because the base looks like it's 8, but again, the exponent is negative x. So 8 to the negative x is the same thing as 1/8 to the positive x. This kind of shortcut on how to determine if it's exponential growth or decay depends on that exponent being an x, not a negative x. So this was exponential decay. So I would say the 2 most commonly missed ones on here would probably be number 2 and number 4 because of that exponent rule. So if you didn't fall into that trap, that's great. You probably don't need to worry about it, but if you did, just make sure that you take a moment to look that over before class on Monday, because there is a couple of those on the quiz. Or at least there usually is. I assume there will be this year too. Okay, the one new thing I need to show you guys today is these are horizontal asymptote type questions, but they're not ones that we can just apply the horizontal asymptote rules to like we did a couple weeks ago. These, we kind of have to reason through them. And try to figure out what's going on with that function without a calculator. Of course, if you have a calculator, you can just graph it, and you can look at the far right of the graph and the far left of the graph to determine what y is approaching. So my tip on these questions, and again, just trust me on this for now, and then if you come up with a better strategy, of course you're welcome to use it, but what seems to help students the most is to have 3 different things memorized and ready to use. Every one of these questions will use at least one of these 3 things I'm about to tell you. So the first one is if you have a number, if the exponent's headed to 0, then this whole thing is headed to 1, because anything to the 0 power is 1. So if our exponent heads to 0, we can just change that whole thing to 1. If you have a number whose exponent just keeps getting bigger, then this whole thing just keeps getting bigger. bigger your exponent gets, the bigger the overall number gets. And then, so both of these two I think should make sense to you, if you remember this exponent property at least. The last one's not as intuitive, but if you have a number and its exponent is headed to negative infinity, it just keeps getting smaller. That's the same thing as 1 over n to the positive infinity. Remember, negative exponent in the numerator is like a positive exponent in the denominator. This is the same as going to infinity because of this second property. And in a fraction, if your numerator stuck still, but your denominator just keeps getting bigger, then this whole fraction heads to 0. So, every one of these questions will use one or more of these three things. So in my opinion, I think it's worth memorizing those three and actively be looking to use them for these questions. Okay, so let me show you this with 9 and 10, and then I'll let you do 11 and 12 as guided practice. So if I want to start off with this guy, it doesn't matter which one you start off with, but I'm going to just plug in negative infinity for x. Okay, and then I'm going to try to figure out what's happening with this fraction when as my x goes to negative infinity. Well, if you memorize those three things that I just said, this is one that you immediately can replace. If you have a number, no matter what the number is, e is just a number, if the exponent goes to negative infinity, then that whole thing goes to 0. And if you know that goes to 0, you know your whole denominator goes to 2, and your whole fraction goes to 7/2. So again, it's not that you couldn't have figured that out without memorizing this one, but since it comes up a lot and that's a quick, nice substitution, I think it's worth knowing that one. Okay, but if it said positive infinity, second half of the question, the right side of the graph, now you need to think about what e to the positive infinity goes to. So this is the second one I have listed over there to the right. If you have a number and the exponent just keeps getting bigger, and this guy just keeps getting bigger as well. If you add 2 to a number that just keeps getting bigger, it's just going to keep getting bigger. Just gets there 2 faster, but in the grand scheme of things, that's not really doing much of nothing. And then once again, in a fraction, if your numerator stuck still, but your denominator keeps growing, your whole fraction gets closer and closer to 0. And just for once, just in case that doesn't make sense to you, I'll just show you real quickly with the calculator. As you take 7 and start dividing it by bigger numbers, it doesn't even take that big of a number before it gets pretty close to 0. And if you divide it by too much of a number, okay, well, if you divide it by too much of a number, your calculator is even going to have to get into scientific notation because that number is so small. So anyway, that's why that heads to 0. So again, I knew I was going to use at least one of these three per question. Had those memorized, plugged in negative infinity, thought about what happened to the function, came up with 7/2, then plugged in positive infinity, thought what the function would do, and it went to 0. Okay, let me show you one more, and then I'll have you try 11, we'll go over it, and have you try 12 and go over it. Okay, so same idea. We'll take the function, whatever they gave us to work with here, and we will plug in negative infinity one time. And you just need to make sure that you're doing this in small enough chunks that you can keep up with what's going on. So I'm leaving all of this alone. I'm only going to try to figure this part out for a second. Now I know 2 over infinity, if the numerator stuck at 2 and my denominator keeps growing, that would go to 0. But a positive divided by a negative is negative. However, 0 is the only number that doesn't matter if it's positive or negative, because this is like negative 1 times 0, which is the same thing as 0. So now this matches up with the first thing I suggested to memorize. If you have a number whose exponent's headed to 0, that whole thing heads to 1, which means the whole denominator's heading to 2, which means the whole fraction's heading to negative 5/2. Okay, instead, if I plugged in positive infinity instead of negative infinity, it's going to look like this. So my approach is still basically the same. Leave as much of this alone as I can, so I can just take a small, tiny, manageable chunk. Positive 2 divided by a positive infinity. Positive divided by positive is positive. 2 divided by a number that goes to infinity is going to go to 0. And positive 0 is really the same thing as just 0. So once again, we're using the same property here. A number whose exponent heads to 0 heads to 1 overall. So once again, the denominator heads to 2. So the fraction heads to negative 5/2. So with these two examples, I want you to see that the numbers can approach the same thing on the left and the right, or the numbers could approach two different things. It just depends on the function. So sometimes same number, sometimes different number, but I don't want you to think they're supposed to be different. I don't want you to think they're supposed to be the same. So go ahead and give your best shot to number 11, and then we will check it and see if you did it correctly. So see how that goes. Go ahead and try to do both parts of that question, please. Okay, let's make sure that you did this correctly, and actually I might be able to come up with the answer, so then you know if which part you need to pay attention to. I believe this is 0 and -2. Is that what y'all are getting? Okay. So if you did not get, if you did get that, go ahead and just move on to start question 12. You can start question 12 a little early, but if you did not get 0, one of your steps should just show plugging in negative infinity. Just do as little as possible. Don't try to do too much. Then maybe just do these two. 5 times a number that keeps growing is just going to keep growing, and a negative times a negative is positive. then you could just work this part of the question. Now again, I think you should be able to reason this. If you got a number like e and you just keep making the exponent bigger, then this whole thing just keeps getting bigger. But it's also one of the three things I said you would use in most of these questions, so hopefully you can substitute that pretty quickly, which means the whole denominator is going to infinity, because subtracting 3 from that doesn't do next to anything when you're talking about extremely big numbers. And then finally, if your numerator is stuck still but your denominator keeps growing, your whole fraction is going to approach 0 over time. So that's where the first answer came from. Okay, if you did not get the -2, the difference would be this would have been plugged in a positive infinity. 5 times infinity would still be infinity, but now a negative times a positive would be negative, and a number that goes to negative infinity doesn't go to infinity. This is one of the other three things. This is the one I said that's less intuitive. So you could change it with exponent rules, and a step or two later you should be able to figure it out, but the quickest way is to just memorize that one so that you see that goes to 0, which means the denominator goes to -3, which means the fraction goes to -2. So again, we're just trying to predict what's happening at the ends of the graphs by thinking about plugging in really big or really small numbers. Okay, make any corrections you need to there, and then try one more time for me on question 12. All of this would go to 0. Are you talking about all of this that's highlighted?
No, I'm talking about just
Just the what?
just negative infinity. Doesn't that just go to 0?
Negative infinity? No. Negative infinity is totally different than 0. E to the negative infinity goes to 0. Is that what you're asking? Yeah, so e to the negative infinity goes to 0 because you could think of this as this, which is the same as this, which heads to 0. But no, the negative infinity is like the smallest number you can ever think of. It's far from 0. Okay, give you just another moment here. Okay, I believe the answer to both of these should be 1. Anybody else get 1? A few ones? Okay, so it's probably fine then. Again, I'm trying to do it in my head, so that's a little bit harder. If you did not get 1 for the first one, now if you got 1 for both of these, you can go ahead and move on. Those 2 worksheets we did last class, I did worksheet 1 for you on the front. I skipped 1 question. It was this type of question, so you should be able to go back and finish it up now. And on the back, I said skip that question on the back, because we hadn't talked about it yet, you need to go back and do those two before you turn those in. But if you did not get that, let's try to figure out what went differently. So, just this exponent, a negative divided by a negative is positive, and 4 divided by a number that just keeps getting bigger would go to 0. A number whose exponent goes to 0 heads to 1, which meant the denominator is going to 4, the numerator was at 4, so the fraction was heading to 1. Okay, if you plugged in positive infinity instead, now you have a negative divided by a positive, which would be negative. 4 divided by a number that's increasing goes to 0. But 0 is the only number that's the same whether he's positive or negative. So this also really headed to 1, which made the denominator go to 4, which made the fraction go to 1. So once again, we saw 2 questions where they headed to the same number and 2 questions where they headed to different numbers. So it can be either way. I'm just making sure you don't think they're supposed to be the same every time. It just depends on how the function's set up. I guess if you really paid attention to 10 and 12, there's something about those functions that made them go to the same number, and then 9 and 11 were different, so they didn't go to the same number, but that's really unnecessary to try to learn that, to memorize that. Yeah. Uh-huh. Because if you take a number like 4 and you just keep dividing by bigger and bigger numbers, that's already too big. It's going to head to 0. But it was a negative divided by a positive, which made it a negative 0. But negative 0 is the only number that's the same as positive 0. So that's why we ended up with the same answers on that one. Anytime you have a number divided by infinity, that's going to go to 0. Just going to get closer and closer to 0 as that denominator gets bigger. Okay, so that was the last of the new information. So again, when we started this algebra this semester, I kind of told you guys a lot of times it's pretty short and sweet. So we hope that you remember most of this from last year, so we hope that it's easy for you. But if you didn't learn this stuff last year, then you're going to have to put in more effort. If you learned it but you forgot it, then you got to put in more effort. This is all stuff that is important for you to know as you guys move on. So every year this happens quite a bit. So I said this less than 5 minutes ago, but I'm going to say it again real quick. We skipped 1 question on number 90 and we skipped 1 question on 91. You have to go back and finish those to get full credit on your homework. So do that first, please. Then in Google Classroom this morning, I opened up 90, 91, and 92 so that you can turn those 3 things in. And you should have an idea of what question types you're most worried about. So if you need to study, you've got a good chunk of class time to study. And of course, I'm here to help you. So it's in your best interest to just go ahead and get your studying over with now. But also, please make a reminder about the quiz, because it will not be till next class, which is next Monday. So almost a full week from now, you are very likely to forget about it. So it's not meant to be a hard quiz. It's meant to be pretty straightforward from those few handouts. But again, if you didn't learn it last year or you forgot it from last year, then you're going to have to put in a little more effort than everybody else. So I think that's the last thing I've got for you, at least up on the screen, until you guys come up with any questions, if you have questions. But for those of you that did the ACT yesterday, how did that go? Any strong opinions on if it was easier or harder?
It seemed easier.
Easier than last time? Well, unfortunately, if everybody thought it's easier, you might not get a higher score because ACT is like a sliding scale. So if the average is high, they consider it an easier test, so you have to get more points to get to your number. And if the average is low, they consider it a hard test, and you need less points to get to your number. So if everybody thought it was easier, you might not score better. But you guys remember what kind of trig was on there, or if there was much trig? Just one?
Yeah, there's probably like a tangent.
There was compound interest. But
Oh, was it?
It was with natural log. Yeah.
Was it something?
It like had like part and stuff, but then it's like I don't know.
So you couldn't figure out what the difference was based on what we did.
I knew the difference.
Oh, okay. Do you think you would have gotten it if we hadn't just reviewed it?
Maybe.
Okay. My B-Day classes haven't had the same lessons y'all did, so they didn't have that reminder, but good. I'm glad it went okay for you guys. ACT is probably one of the most important tests y'all will ever do, so. Just on the topic of ACT, I haven't heard anyone talk about it this year, but in past years I have heard that Naviance has a good ACT prep built into it. I think it like maybe asks you some questions and then like tries to get you some practice based on what it thinks you're weak at or something. I'm not sure. But if you end up not being happy with your ACT score and you know you need to practice a little bit every day or a little bit every week, you may look into that Naviance because students have told me that was good. All right, if you guys have any questions about what you need to do with the rest of class, please let me know. And if there's any math questions I can help you to prepare for this quiz, then also please let me know. This quiz will be a no calculator quiz, so don't plan on just using your calculator to answer all of that.